All right, living environment fans, it's Tuesday and it's time for today's Bellringer. And we've been talking about immunity and talking about viruses. Yesterday we talked a little bit about smallpox. Today I want to talk a little bit about the flu and reasons it's important to get a flu shot. Not everybody likes getting shots, but remember the flu shot's not really all about you. It's about all of us. And anyway, we'll talk about that as we go. But let's do today's Bellringer first. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. The flu makes you feel terrible, right? It makes you feel awful. It's a virus that affects your day-to-day life, and most of us have experienced the flu, at least in one form or the other, and it's been miserable. What we forget is that the flu, this virus, is the deadliest thing to mankind in the history of our species. It's killed more people than anything else, and it's a deadly virus because it affects your respiratory system cells and causes them to shut down, so you lose your ability to breathe if you have a severe flu infection. And it's estimated just last year, like 9 million people in the United States got the flu. It put 100,000 of them in a hospital, and 5,000 of them didn't get out of the hospital, right? That's 14 flu deaths a day in the United States. All right, so worldwide, it's much higher than that. But yeah, it's still a disease that's no joke. And we want to talk about what the flu is and why you should get a vaccine. Flu is a virus. It's a pathogen, right? It's a virus. Some pathogens are bacteria. You treat them differently, all right? The way viruses work, like the flu, is they bind to your cell membranes, right? They have the right antigen. It binds to a cell receptor in your cell membrane, and it basically sneaks into the inside of your cells. So here's that virus. Whoop, there it is. It's in. It's in. Right? What's interesting about that is that each virus is typical to one different type of cell. So like the flu, for example, it only attaches to respiratory system cells. So like the flu doesn't actually attack your digestive system. The flu doesn't attack your brain. It only attacks your respiratory system. It only has the markers to bind to your respiratory cells. Once inside, what happens is you get a little strand of the virus is just a piece of DNA or a piece of RNA. It's a piece of nucleic acid. And once it gets inside, it hijacks the cell. It basically takes over the protein-making machinery of the cell, so the cells stop making what they normally make and instead make copies of the virus, right? And then in a lot of viruses, they just fill up that cell with virus until they're so full that it just breaks apart, and now you have thousands of copies of the virus to go infect other cells. And they do this over and over and over again. So what's in the shot, right? If you want to get the flu shot, they actually give you kind of a deadened virus version of the flu. You get the flu with all of the antigens on the outside, but none of the DNA on the inside. And you inject that into the person, and what happens is their B cells start to recognize this foreign invader, and they make antibodies. The vaccine produces new antibodies. Then the antibodies float around, and if they see the disease, they hook onto it, right? They latch onto the disease, and that targets them for destruction. Who usually destroys these? Well, there's two of them. There's our old friend, the macrophages, and then there's another type of cell called a T cell. T cells, but the one I find most interesting are the cytotoxic T cells, because they basically recognize the antibody, and if there's a cell with an antibody on it, they cause that cell to kill itself. Here's a T cell working on an infected cell. Yeah, here's a T cell working on infected cells. See how they kind of blow themselves up? That's what T cells do. Right? They cause cells to kill themselves, cells that are infected with virus. So your flu vaccine, it basically trains your B cells and your T cells to kill infected cells before too many of them get infected and you feel sick. How cool is that? I get vaccinated Even if you're a healthy person, remember, it's not all about you. If you get vaccinated, you won't actually develop the disease and you're less likely to spread it to somebody else, right? Who dies of the flu? Basically very old people and very young children, right? That's who dies of the flu, and people with compromised immune systems. So you getting the flu shot as age 15 is not really, right? Well, you probably survived the flu if you got it. What it is designed to do is to protect you from passing it on to somebody who wouldn't survive, right? And that's one of the reasons why you encourage everybody to get the flu shot every year, is to reduce the amount of deaths due to the flu virus. More in class, 1918 was like just a little over 100 years ago, was the biggest flu epidemic of all time. And we'll talk a little bit about that in class. So today we've got Bellringer. You can watch a little stuff about why to get vaccinated for the flu, and then we'll talk a little more about the flu of 1918. All right, let's go.